Here's what you're going to work on. You're going to get 4 descriptions of somebody on a swing, and you're going to have 4 graphs representing these functions of somebody on a swing. So you're going to match them. I'm going to put it up here so you don't have to flip back and forth. You're going to match each function with each graph. Then, the next thing I need you to do is label the x and y axis for each, all right, using units. So match them, and then label your x and y axis for each. Before we label, let's talk about this. What are the 4 different names for the x values? I'll take one, x value. What's another one, Ava? Independent variable. Caleb?
Horizontal
axis. It is on the horizontal axis, but that's not a name. So I have, what did I say, x, independent, Sean? Input. And then the fancy one that you guys don't like using, Cam, do you remember?
Is it like the range?
Oh, it's like that, but it's not the range. Domain. And then the y values, one would be range. What else? What else for y values? We got range and y value, Sean? Dependent variable, and then output, right? So we have multiple names for some of these things. Keep that in mind as you're reading your statement. So match the statement with the graph. Label your x and y axis, please. Who can tell me which one corresponds with A? Which function goes with A? All right, Maddie. Are you serious? Okay, amount of time left. So if R goes with that, Maddie, what do you have for my x axis? Time in seconds, yep. And then what about the y axis?
It's the amount of time left, like on this.
Yeah, so it's still going to be time in seconds, right? A lot of time, and then over time, there's less time. Not often do we have the same thing on the x and y axis, right? That one's kind of, it makes you think for a second, right? So that makes sense. They start with 30 seconds, even though there's nothing given, and then they'll go all the way down to 0 seconds. So that is, A goes with function R. Okay, B. Zeph, which one do you match B with?
I match S.
Function S. So what'd you put for your x-axis?
For my x-axis, I put time.
Time in seconds. Then what about your y-axis?
For my y-axis, I put the amount of times that the adult pushes.
Yeah, pushes, right? And then let's make sense of what this function looks like. Do you see how the amount of time between pushes gets longer and longer? Why would that be in context? Think about a swing. First push, they're not going very far away. Second push, right? It's getting further and further away. Makes sense in context, right? And then notice, why is it not connected? Sean?
Because, like, it's just one push per line.
Yeah, there's no partial pushes, right? Some weak second push is still a push, right? No partial pushes. All right, C. Let's go with this color. Meredith, which one did you match C with?
I think it was either like the distance from the swing. I think it was the distance from the beam.
From the beam, which is D, yeah. Because if that swing is swinging, right, and you got the rope going down to the swing, kind of like the radius of a circle, it's always going to stay the same from the beam. So here's our times in seconds, and here's our feet. And then the only way you could kind of change this is maybe it's a little closer, maybe a dip at the end sometimes, like, you know, you get up there real high and there's that little bit of slack, you're kind of living. But in this case, it's just staying the same, right? The distance from the beam is always the same. And then D. Sophia, which one you got for D?
Function H.
Function H. So the height of the swing from the ground over and over, right? So we've got a time in seconds, and then we've got the feet. Cool. Now, let's talk about domain and range. Possible inputs, possible outputs. So let's handle all the domain. Domain, what do you notice about all of our x-axes?
They're all the same.
They're all the same. It's all time. For how long? 30 seconds, because in the premise, that's what's given. So the domain is going to be 0 to 30 seconds. But I also want you to write this a different way as well. I said 3 there. I want us to practice writing this as well, this compound inequality. And what this is saying is x value, or the domain, has to be more than or equal to 0 and less than or equal to 30. And it's everything in between 0 to 30 seconds, right? Yep, you did this yesterday on the Desmos. Now what we're going to focus on next is the range, because that could be different for each one. All I want you to do to start is put reference dots for where your eyes are going to go to find the range for A, B, C, and D. So just dots. Where are your eyes going to go to figure out the range? Again, the range is going to be which values? X or Y? Y values, okay? So just put reference dots down. Don't make a range yet, just reference dots. Let me show you where I got what I got going here. For my range on A, I looked here and here. Okay, and so for the range for that, we know, we don't know, oh, this one we actually do. It has to be 30 seconds, right? 0 to 30 seconds for the Y, right? So this would be the range. And you could have that in words too still. We're working towards this, but 0 to 30 seconds for the range there. Because it starts at 30 seconds and goes down to 0. For B, we're looking right here. Oh, let's change the color. I had colors, let's change the color. I would look right here at 0 pushes and up here at 5 pushes. So my range for B would be something like 0 to 5, but it has to be whole numbers. You guys good with that? It has to be whole numbers. So that means 0, 1, 2, 3, 4, 5, nothing in between because we don't have partial pushes. For C, I'm looking anywhere on this line, right? And I'm going to say something like the range Y equals, how far away do you think that is? How long is one of those chains? 8 feet? 10 feet? It doesn't matter. Whatever we say, that's what it is. Let's say 10 feet. And if it's a 10-foot chain, you know, the double chain down to your swing, it's always 10 feet away from the bar. And then D, I'd be looking right here at the bottom and right here at the top. And my range for D would maybe be everything between, what do you guys think? What's the lowest? How far off the ground are you? 2 feet?
Yeah.
2 or 3, whatever. And then the highest you probably get off the ground is a good 7 feet maybe?
I don't know. I used to jump off the swings.
I know, but if you're thinking about how high you are, this is like 6, 7 feet. That'd be pretty high for the tushy on a swing. So I don't know.
Yeah. But if I'm standing here.
But you fly off a swing, you're feeling much higher than you are.
Yeah.
I'm still a jump off the swing kind of
Also,
guy.
Even if you jump off like a.
In fact, I'm a jump and do like a half turn, face the swing when I hit. That's my move. But I'm gonna guess 7.
I say you could do that on skis then.
Either way, low to high. Everybody good? So big picture, domain's going to give us our left to right, our possible x values. Range is going to give us our minimum and max up and down. So h of 0. Is 0 my input or my output? Input. So 0 in gives me 6 out. In context, what does that mean?
0 seconds, the ball is 0 seconds.
Yeah, dropped from 6 feet. Right? Drop from 6 feet. Okay? H of x equals 0. In that case, is 0 my input or my output? Output. And do you guys remember that homework quiz where there's multiple answers for some things? We got those multiple answers again. So this is saying at what time does the ball touch the ground in context, right? Well, it's going to hit the ball at 0.54 seconds, 1.48 seconds, 2.25 seconds, 3.1 second, and it looks like it wouldn't be 6, would it? Maybe 3.8? 3.8-ish?
Oh, yeah.
Yeah, because the scale is 0.25 per. Yeah, 3.8-ish. Okay, and then maybe it actually continues, but we don't see the rest, but we could stop there. So the domain is all possible x values. So who can get me a solid domain for this? What are the possible x values, Sean?
Probably from 0 to 3.8.
Yeah, to that 3.8. Okay. I like that. So 0 to 3.8 seconds. Or we could say it from when the ball's dropped to when it stops. That's another way we could to when it stops, because maybe it could keep going. Maybe there's another bounce in there. I don't know. Okay, and then the range. Who can help me out with the range for this then? So all the possible inputs are 0 to 3.8 seconds. Did I write 30 here? What are the possible ranges? Hey, Ivy.
0 is less than or equal to y is less than or equal to 6.
Yep, so the lowest it goes is the ground, the highest it goes is where it starts at 6. and everything in between. So there's my domain, and there's my range. Awesome. You guys are going to do the cool down next. You can just do it on any open area in your notes.
Oh,